We've always been yearning for this sight. The universe has never before been seen in such depth. Never before has humanity been able to peer so far into the past of the cosmos and with such clarity. The countless unnamed galaxies you can see began to generate light just a few cosmic seconds after the Big Bang, over 13 billion years ago. Some of the best scientists and engineers in the world have worked diligently for more than 2 decades to achieve this photograph and the countless thousands that will follow. From conceptualization to building and testing, from launching to deployment and commissioning the icy depths of space, from exposing its new eyes to the cosmos to collecting and analyzing data to guarantee it sees more clearly than ever before. When we look back on Webb's most astounding scientific discoveries, 30 years from now, half of them might be what we want to do, and half will be incredibly intriguing discoveries that we haven't even reflected on yet. These are only the opening pictures. Consider the numerous years of photos and other findings we will make with this telescope, even regarding possibly habitable planets. Not just from the initial photographs, but also over time, we'll learn a lot about it. And I'm even having a tough time imagining what it may be or how far this will go. Welcome, and you are watching Technology Zone, where the home of technology resides. Join us as we discover the features and other aspects of the JWST in this video. The James Webb Space Telescope, or JWST, a unique observatory designed to reveal how the cosmos initially started to glow and much more, is our great photographer. It will be an amazing first year for Webb science. According to researchers, most of the 20-year-old initiatives will be put into action this year so that people may see the first galaxies to form and the first light of the cosmos. We shall investigate the planetary atmospheres of other stars. We will be able to see for the first time the surface properties of solar system objects that are simply too weak for our present telescopes to detect. In this progression, it will be remarkable how quickly science advances. The biggest, most complex space telescope ever created is expected to provide some of the most amazing discoveries during our lifetimes and beyond. It has been 13.8 billion years since the Big Bang. The Hubble then looks back approximately 13.5 billion years, but they can see every single galaxy. How did it evolve into galaxies from nothing? We cannot look into that time period, therefore something must have to happen, right? This telescope is intended to allow us to see into a formerly unexplored area of the cosmos. The so-called Dark Ages are thought to be the period during which everything must have occurred, including the creation of the earliest galaxies, stars, and black holes. According to scientists, the light itself had been stretched throughout time as the universe expansion stretched the space-time continuum. That light has been traveling throughout the cosmos for 13.5 billion years, getting redder as it goes. Because it needed to view farther than the Hubble Space Telescope could, it had to be infrared. Traditional telescopes are tubes with mirrors, lenses, and other components. Warmth emanates from the tubes. Any structure or facility we have is naturally warm. It heats up just because sunshine is shining on it. It produces heat on its own if it is warm. According to scientists, they must essentially turn off the telescope's light in order to use an infrared telescope. They do this by bringing the temperature all the way down to negative 380 degrees Fahrenheit. Thus, the telescope disappears. And they had this exposed mirror. A spindly, secondary, and enormous sun shields because of those factors. All of it is done to maintain the telescope and its mirrors at the lowest possible temperature. Even if a honeybee were to buzz around on the moon's surface, this telescope could still sense its heat. Indeed, such is the sensitivity of this telescope. So scientists need as much so they can get the telescope alone chilled all the way to this cryogenic temperature of negative 380 degrees. Even scientists admit that they used to giggle a lot because they didn't know how to accomplish this in the beginning. Therefore, in those early years, the main focus was on identifying the technologies that were still lacking or what at the time didn't exist, and then setting those out in a methodical way to show how we can get from something that doesn't exist to something that does exist. The 6.5-meter segmented mirror on the JWST is more than just the observatory's eye. It serves as the most crucial component in the lifeblood of the entire structure. It has never been manufactured before and is unlikely ever to be made again. It is less of a mirror than it is a monument to what humans are capable of when scientists work together for the sake of unbiased discovery, both in terms of design and functionality. It actually required absolute will to bring this entire tremendous privilege for us. Each segment has actuators that can change the curvature of the segment by millimeters. Here are thousands the size of a human hair. They will collectively make sure that the 18 major parts are arranged to form a single monolithic reflector or mirror. Because the 18 pieces are initially facing in various directions, it is virtually like having 18 different telescopes. Quite many, huh? Although each piece is a different eye in the sky, they actually all share a secondary mirror. These mirrors are difficult to use. 6 of the 7 actuators on each significant mirror segment move the segment's stiff body, allowing it to tip and tilt, move forward and backward, and even gently rotate. This gives each part 6 degrees of freedom. According to scientists, there couldn't be any waves larger than around 3/4 of an inch in this mirror, even if you extended it out over the Atlantic. So this has to be as seamless as possible, but not at normal temperature. This had to be clean at negative 308 degrees Fahrenheit. In this way, every substance can be bent and turned. We start with it at ambient temperature and cool it all the way to what scientists refer to as this really low cryogenic temperature. Therefore, the only way scientists were able to do this was by wrongly polishing each part. They released it just as is at room temperature. They completely chilled it down, then it would flex and twist. They would also meticulously measure all of those bends and twists, rewarm them, and then smooth out all of those mistakes so when it completely cooled again, it took on the precise shape they had intended. That proved to be such a difficult task, and the Marshall Space Flight Center had to build this enormous test chamber just for the group of scientists who were working on this project. They needed the proper substance that would indeed predictably bend back into the desired form. Cryopolishing, as you may be aware, essentially meant that scientists had to polish it incorrectly but perfectly incorrectly. As a result, after it cooled, it returned to its original shape. As an outcome, when they combined all of these segments and utilized electronics and actuators to align them, they were able to create a 6-meter primary that was exceedingly smooth and had the desired picture quality. JWST is a facility for the future, even though it will be able to observe farther and more vividly into the previous era than any observatory that has gone before. The next generation of scientists will use it as a discovery engine, opening up new perspectives of the cosmos. These scientists have laid the groundwork. Nevertheless, it is now up to others to advance the field of science. JWST could discover the first proof that life began both here on Earth and beyond. Could a single telescope rewrite all of the cosmological chapters in our books? The opportunity to know this one out is now and in the future discoveries of this invention. There is no doubt that it will significantly alter the way we view the cosmos in my perspective. In my view, many scientific advancements and forthcoming discoveries will be something we haven't even imagined yet. Some of you might have questions like, when do black holes begin to develop? What takes place when black holes develop in the galactic centers? How do the gas and stars within these galaxies interact with those black holes? How does the galaxy alter as a result? In what ways does it change the black hole? What impact does it have on how light escapes and spreads throughout the universe? Exoplanet science will be discussed, including looking at some of the closest and brightest exoplanets in an effort to study their atmospheres. When scientists initially discovered exoplanets, researchers thought they might resemble Earth or our solar system. What they found, however, is that there are considerably more exoplanets than our initial models said were conceivable, coming from a great diversity of different solar systems. Additionally, scientists and researchers will make observations of our solar system. They were observing Jupiter's Great Red Spot and distant Kuiper Belt particles to understand their surface chemistry. The first year that Webb is in service will see the completion of all that science. It's going to be a lot of fun. It's only the beginning when the first light breaks through the darkness. We have arrived at this historical time as the science of JWST commences, thanks to billions of dollars and decades of devotion. But all of this is but the beginning step of a discovery adventure that will bring us from the earliest cosmic daybreak to the furthest reaches of the cosmos. What enigmas and riches lie in wait for us along the way, in the sky's unknown depths? We'll soon find out. At this point, I'm sure we can all recall a time when we tried to get a piece of the space but couldn't do so. Let's discuss it in the comment box below. What space information do you think would be discovered by the future generation of science? Don't forget to subscribe to our channel for more weekly stuff like this, and give this video a thumbs up if you enjoyed it. And again, this is Technology Zone. See you guys in the next one.